All right, so here we are. We're going to do matched pairs, excuse me. This is 2006 Form B. It is one of the FRQs that I asked you to do earlier. You can read it. They talk about a 6-week program to increase manual dexterity for people who complete the program. We have, notice what I did up here. I highlighted what I thought was important. Random sample of 12 people enrolled in the training program was selected. A measure of each person's dexterity on a scale of 1 to 9 is recorded just before the start and just after the completion of the 6-week program. Here are the data. So we've got 12 people. We've got before the program started their scores and after the program started their scores. So what I did was I took this before the program and I put it in list 1. So I went stat edit on my calculator. List 1 contains the before program scores. List 2 contains the after program. Now, when you stop and think about what we expect, because we expect an increase in manual dexterity, I chose to have L3 be L2 subtract L1. So I'm going to go over to my calculator and let me see if I can get this to show you what it is that I'm doing. Nope, not that one. That one, I think. So what I'm doing on my calculator is I'm going to highlight L3 and I am going to press L2 subtract L1. The reason I chose to subtract in that direction is because I expect improvement, so I expect the L2 numbers to be bigger. So I did that while I had L3 highlighted, L2 minus L1. Now that list will populate with the differences. So I have all the differences there, and it's that list that I am going to sit and play with. I don't really care about list 1 and list 2 anymore. All I really care about is list 3. Now, that brings up an important point. When you put the scores in for L1 and the scores in for L2, we have to make sure and be careful to keep them in the matching order. Otherwise, when they subtract, you're going to be subtracting, say, person A minus person B or something, and you don't want that. All right, let's talk about what we want next in our test. We're going to see what it says. Can one conclude the mean manual dexterity for people who've completed the program has significantly increased? When you see the words like you see here, support your conclusion with appropriate statistical evidence, that's an indication that you should be doing a phantoms test. So here's what I did. I started in step P, excuse me, by defining what mu D is. Mu D is the true mean difference in manual dexterity after the program. And then I have to make sure in a matched pairs test that you define which direction you are subtracting. And that becomes important when you come down here into step H. In step H, when you write your null hypothesis, the null hypothesis is nearly always that the mean difference is 0, that there's no difference before and after. But the alternative, that we want to see an increase in manual dexterity, the true mean difference is greater than 0. If I had chosen back here to subtract L1, subtract L2, I would have expected more negative numbers here, and I would have to have a less than sign here instead of a greater than. So you want to make sure you've got that going on okay. Now again, I haven't touched my calculator at all yet, aside from making those lists. So here I am. They did mention a random sample of 12. They also, independent, we can assume that it's a reasonable assumption to assume that there's more than 10 times 12. I forgot to write the 10 times 12 on there. And the normal condition, now n is 12, we have a very small sample. So what I chose to do was I chose to come over here to my calculator and I went second y equals, got to my stat plot. I'm going to turn a stat plot on And I'm choosing, for a very small sample, I kind of think that an NPP plot is a nice, easy, appropriate thing to do. I could also have made some dot plots or histograms or something. You can really choose, a histogram, an NPP, a dot plot. In some cases, you might choose a box and whisker plot, but there's some discussion over whether that's appropriate or not. I'll see if I can make this bigger for you. I then came and did, let me see which one is it. I think it's, there you go. Now you've got a better view of what I'm doing to get that NPP plot. So I turned it on. I chose NPP, which is this last one. My data list is in list 3. And now that I've got that all set up, I'll hit graph. And then you may have to do a zoom 9 if things don't look right, and they usually don't the first time. So what I did was I copied that that NPP plot as carefully as I could, right from my calculator. Notice I've got, the axes. I kind of, at this axis, the y-axis is z-scores for an NPP, and the x-axis is your data. So you put your data in order from small to big, you record the z-scores, and that's what you do for an NPP plot. And if you recall, with an NPP plot, what we're really looking for is we are looking to see, is this NPP approximately linear? And if it is, then we can say that our data is approximately normal. Linear and normal do not mean the same thing, so we have to make sure we specify. And this is not actually data in here. These are z-scores. So let's be cautious about that wording. I've identified what this picture is, and I've stated why it's here. And that's what the graders are looking for. All right, so now I'm on to step N. I'm doing a matched pairs t-test, and I also gathered my data. Do you recall where that data came from? I went stat, I scrolled over to calc, and from there I did a one variable stat. Now think about where your data is. I told you a minute ago that you're only interested in list 3. I'm no longer interested in L1 and L2, so I put L3 here. Some people are having trouble with the frequency list. You leave that blank, and then you hit calculate, and then your calculator will not give you any errors. So I've got a mean. I've got a mean right here. I've got a standard deviation right here. My n is 12. That all looks lovely. All right. So next up, let's keep going down our list here. Oh, look at that. So next up, I'm going to calculate my t-score. So I plug in my values. X bar D is 0.375. That's what I just had on my calculator. Mu D is 0. That's from your null hypothesis. SD from my calculator, and N was 12. I got 3.54 approximately. Now, one thing that you might notice, what I've been wanting to share with you guys, and I haven't had a good way to share it until recently, let's take a look at what we have here. When I click stat, you might remember a couple chapters ago, if you scroll all the way to the left to tests, you think about what it is that we're doing. We are doing a matched pairs t-test. A matched pairs t-test is a one sample t-test. So what do I want to pick from this list? I want to pick number 2, a t-test. I hit enter. Now I have a choice of either data that's sitting in a list somewhere, or if they didn't give you data to put in a list, you've got statistics in a problem. In this case, we've got data sitting in a list somewhere. So I'm going to choose data. Then here is what is your null hypothesis. Mu is equal to 0 for us. Where is that data? That data is sitting here in list 3. Here frequency 1 is fine. Now this part where it says mu not equal to, less than, or greater than mu 0, that's the really important part, because you want to make sure that whatever you choose down here matches your alternative hypothesis. And remember, we expected those values in L3 to be positive, so we're going to pick greater than when it comes to that step. And then I'm going to go and I'm going to hit calculate. And this is where the magic happens. Look at that. There is the t-score that I wrote down over here. You want to double check, use this as a double check. You want to make sure that whatever you've written in your formula when you plug numbers in, make sure that it actually equals 3.54. Otherwise, a grader will take off points for that. Here's my p-value. Remember, on a z-chart or on a t-chart, you don't get an exact p-value. Here we do. So that's kind of a nice thing. A lot of people I know were complaining that they didn't know about, were not comfortable with that issue. So there I've got my information. Now I can take that calculator and set it aside, and now I can move forward with my decision making. So here I'm going to say that my p-value of 0.0023, it's smaller than any common significance level. There was no significance level mentioned in this problem, so I could use any significance level I want, and anything that I would choose within reason would be bigger than 0.0023. So I continue on and I interpret that. This evidence suggests that there is an increase in manual dexterity after this program. That's a great little problem for you to take a look at. I wanted to demonstrate the calculator. I wanted to demonstrate the NPP and try to clear up some